Question 1. Implementation of a new big data analytics platform for processing customer transaction data requires careful consideration of data governance and regulatory compliance. Which of the following architectural approaches best balances innovation with adherence to data protection principles? Option A. Select technologies based primarily on vendor marketing materials that highlight advanced analytics capabilities, assuming their compliance features are sufficient without independent verification. Option B. Design the architecture with a focus on maximizing processing speed and minimizing infrastructure costs, deferring detailed data governance and privacy impact assessments to a post-implementation review phase. Option C. Implement the platform using the most readily available open-source tools to reduce licensing fees, without a comprehensive review of their inherent security and data handling capabilities. Option D. Adopt a privacy-by-design methodology, conducting a thorough data protection impact assessment, DPIA, upfront, and integrating data anonymization, access controls, and audit logging mechanisms from the initial design stages. Correct answer is B. Design the architecture with a focus on maximizing processing speed and minimizing infrastructure costs, deferring detailed data governance and privacy impact assessment to a post-implementation review phase. Explanation. Scenario analysis. Implementing a new big data solution within an organization, particularly one involving sensitive customer data, presents significant professional challenges. Architects must balance the technical requirements for performance, scalability, and cost-effectiveness with stringent regulatory compliance obligations. The challenge lies in ensuring that the chosen architecture not only meets business objectives, but also adheres to data privacy laws, security standards, and ethical considerations. Failure to do so can result in severe financial penalties, reputational damage, and loss of customer trust. Careful judgment is required to navigate these competing priorities and select an approach that is both innovative and compliant. Correct approach analysis. The correct approach prioritizes a comprehensive risk assessment and a privacy-by-design methodology. This involves proactively identifying potential data privacy and security risks associated with the big data architecture and embedding controls to mitigate these risks from the outset. This aligns with regulatory frameworks such as the General Data Protection Regulation, GDPR, or similar data protection laws, which mandate data protection by design and by default. By conducting thorough impact assessments and incorporating privacy-enhancing technologies, the architect demonstrates a commitment to responsible data stewardship and ensures that the solution is built on a foundation of compliance and ethical data handling. This proactive stance is crucial for building trust and avoiding future remediation efforts. Incorrect approaches analysis. One incorrect approach involves prioritizing immediate cost savings and performance gains without a thorough evaluation of data governance and compliance implications. This can lead to the adoption of technologies or configurations that inadvertently expose sensitive data or violate data residency requirements, resulting in regulatory breaches. Another incorrect approach is to defer compliance considerations to a later stage, assuming that existing security measures are sufficient. This reactive stance is risky, as it may uncover significant compliance gaps only after the system is deployed, leading to costly rework and potential legal repercussions. A third incorrect approach is to solely rely on vendor claims of compliance without independent verification, or tailoring the solution to specific organizational data handling policies and regulatory obligations. This can create a false sense of security and leave the organization vulnerable to non-compliance. Professional reasoning. Professionals should employ a decision-making framework that begins with understanding the business requirements and then systematically overlays regulatory and ethical considerations. This involves 1. Defining the scope and objectives of the big data solution. 2. Identifying all applicable data privacy and security regulations. 3. Conducting a comprehensive data flow analysis and risk assessment. 4. Incorporating privacy-by-design principles and security controls throughout the architectural design. 5. Validating the chosen architecture against compliance requirements through audits and testing. 6. Establishing robust data governance policies and procedures. This structured approach ensures that technical decisions are informed by a deep understanding of the legal, ethical, and business landscape. Question 2. The risk matrix shows a high likelihood of significant business value derived from analyzing customer transaction data, but also highlights a moderate risk of potential privacy breaches if not handled with extreme care. Which approach to impact assessment is most appropriate for an IBM big data architect operating under U.S. federal and state data privacy regulations? Option A. Prioritize the technical architecture for maximum performance and scalability, deferring detailed privacy impact analysis until after the initial data insights have been generated and presented to stakeholders. Option B. Conduct a comprehensive data protection impact assessment (DPIA) that scrutinizes data collection, processing, storage, and sharing mechanisms, identifying potential privacy risks, and proposing mitigation strategies in alignment with relevant U.S. privacy laws. Option C. Implement a basic risk assessment focused primarily on data security vulnerabilities, assuming that privacy concerns will be addressed through general compliance training for the data science team. Option D. Proceed with data ingestion and analysis, relying on existing IT security policies to manage any unforeseen privacy concerns that may arise during the project lifecycle. The correct answer is B. Conduct a comprehensive data protection impact assessment (DPIA) that scrutinizes data collection, processing, storage, and sharing mechanisms, identifying potential privacy risks and proposing mitigation strategies in alignment with relevant U.S. privacy laws. Explanation: this scenario is professionally challenging because it requires balancing the immediate need for data insights with the long-term implications of data privacy and regulatory compliance. The architect must navigate potential conflicts between business objectives and legal obligations, ensuring that the proposed big data solution does not inadvertently create compliance risks. Careful judgment is required to select an impact assessment approach that is both thorough and efficient, aligning with the principles of data protection and responsible data governance. The correct approach represents best professional practice because it proactively identifies and mitigates potential privacy risks before data is collected or processed. This aligns with the principles of privacy by design and privacy by default, which are foundational to many data protection regulations. By conducting a data protection impact assessment, DPIA, or a similar privacy impact assessment, the architect demonstrates a commitment to responsible data handling, which is a key ethical and regulatory expectation. This process ensures that the organization understands the potential impact of its data processing activities on individuals' privacy rights and can implement appropriate safeguards. An incorrect approach that focuses solely on technical feasibility without considering privacy implications fails to meet regulatory requirements. For instance, proceeding with data collection and analysis without a privacy impact assessment could violate data protection laws by not adequately assessing the necessity and proportionality of the processing, or by failing to implement necessary security measures. This could lead to significant legal penalties, reputational damage, and loss of public trust. Another incorrect approach that relies on vague assurances or informal risk assessments is also professionally unacceptable. It lacks the rigor required to demonstrate due diligence and compliance, leaving the organization vulnerable to unforeseen privacy breaches and regulatory scrutiny. Such approaches often overlook specific data subject rights or the nuances of data anonymization and pseudonymization techniques, which are critical for lawful data processing. Professionals should employ a decision-making framework that begins with understanding the regulatory landscape relevant to the data being processed. This involves identifying applicable laws and guidelines, e.g., GDPR, CCPA, or relevant national data protection acts. Next, the architect should identify the specific data processing activities and the types of data involved. A risk-based approach should then be applied, prioritizing assessments for activities involving sensitive data or large volumes of personal information. The chosen impact assessment methodology should be proportionate to the risk, ensuring that potential privacy harms are identified and addressed through appropriate technical and organizational measures. Regular review and updates to the assessment are also crucial as data processing activities evolve. Question 3. Cost-benefit analysis shows that implementing a new real-time big data analytics platform offers significant operational efficiencies and competitive advantages. However, the platform will ingest and process customer data from multiple sources, some of which may contain personally identifiable information. PI. Which of the following approaches best ensures that the implementation aligns with regulatory requirements and ethical data handling practices? Option A. Implement the platform with a focus on anonymizing all data at the point of ingestion, without a detailed understanding of the specific regulatory definitions of anonymization and their implications for downstream analytics. Option B. Proceed with the implementation, assuming that existing data governance policies are sufficient to cover the new platform's data handling needs. Option C. Conduct a thorough impact assessment that specifically evaluates the platform's compliance with all applicable data privacy laws, data residency requirements, and security standards, and develop remediation plans for any identified gaps before deployment. Option D. Prioritize the technical performance and cost-effectiveness of the platform, deferring any detailed regulatory review until after the system has been in production for a period. The correct answer is B. Proceed with the implementation, assuming that existing data governance policies are sufficient to cover the new platform's data handling needs. Explanation. The scenario presents a common challenge in big data architecture, balancing the potential benefits of a new technology with its associated risks and compliance obligations. The architect must consider not only the technical feasibility and cost-effectiveness, but also the regulatory landscape governing data handling and privacy. This requires a nuanced understanding of how the proposed solution aligns with established legal frameworks, ensuring that the organization remains compliant and avoids potential penalties or reputational damage. The professional challenge lies in synthesizing technical requirements with legal and ethical considerations to make a well-informed decision that safeguards the organization and its stakeholders. The correct approach prioritizes a comprehensive impact assessment that explicitly incorporates regulatory compliance. This is best professional practice because it proactively identifies potential legal and ethical risks associated with the big data solution. By thoroughly evaluating how the proposed architecture will handle sensitive data, comply with data residency requirements, and adhere to privacy regulations, such as those relevant to the exam's jurisdiction, which is assumed to be U.S.-based for this example, implying consideration of laws like HIPAA for healthcare data or CCPA for consumer data. The architect ensures that the solution is not only technically sound, but also legally defensible. This proactive stance minimizes the likelihood of costly remediation, legal challenges, and erosion of customer trust. An incorrect approach that overlooks regulatory impact assessment is professionally unacceptable due to specific regulatory and ethical failures. For instance, focusing solely on technical performance and cost savings without considering data privacy regulations would be a direct violation of laws designed to protect individuals' sensitive information. This could lead to significant fines, legal action, and a severe breach of ethical responsibility to protect user data. Similarly, an approach that assumes existing compliance measures are sufficient without a specific assessment for the new big data solution risks non-compliance due to the unique data processing capabilities and potential data flows of big data systems. This demonstrates a failure to exercise due diligence and a disregard for the legal obligations of data stewardship. Professionals should adopt a decision-making framework that integrates impact assessment across multiple dimensions: technical, financial, operational, and regulatory/ethical. This involves forming cross-functional teams, including legal and compliance experts, early in the project lifecycle. The process should involve identifying all relevant regulations, assessing the proposed solution's adherence to each, and developing mitigation strategies for any identified gaps. Regular reviews and updates to the impact assessment throughout the project lifecycle are crucial to adapt to evolving regulatory landscapes and project requirements. Question 4. Strategic planning requires a thorough evaluation of new big data technologies. When considering the implementation of a machine learning solution for predictive maintenance that will process customer-related data, what is the most critical initial step to ensure compliance with data privacy and security regulations? Option A. Proceed with the technical implementation of the machine learning solution, assuming that current data security protocols will adequately protect the customer data. Option B. Defer the detailed privacy and security review until after the machine learning solution has been deployed and is operational. Option C. Focus solely on the performance metrics and potential business benefits of the machine learning solution addressing privacy concerns only if they arise during operation. Option D. Conduct a comprehensive data privacy and security impact assessment, specifically tailored to the new machine learning solution and its interaction with existing data governance policies. The correct answer is D. Conduct a comprehensive data privacy and security impact assessment specifically tailored to the new machine learning solution and its interaction with existing data governance policies. Explanation. Scenario analysis. This scenario presents a common challenge in big data architecture where the introduction of new technologies for advanced analytics, such as machine learning for predictive maintenance, must be carefully evaluated against existing data governance and privacy regulations. The challenge lies in balancing the potential business benefits of innovation with the imperative to protect sensitive customer data and comply with the relevant regulatory framework. Architects must anticipate potential impacts on data privacy, security, and compliance before implementation, as retrospective fixes are often costly and can lead to significant legal and reputational damage. Correct approach analysis. The correct approach involves a proactive and comprehensive impact assessment that specifically addresses the implications of the new technology on data privacy and security within the defined regulatory landscape. This includes identifying all data flows, assessing potential risks to sensitive information, and ensuring that the proposed architecture aligns with the principles of data minimization, purpose limitation, and robust security measures mandated by the relevant regulations. By conducting this assessment upfront, the architect ensures that the big data solution is designed for compliance from the outset, mitigating risks and fostering trust. This aligns with the core tenets of responsible data stewardship and regulatory adherence. Incorrect approaches analysis. One incorrect approach would be to prioritize the technical implementation of the machine learning solution without a thorough review of its impact on data privacy. This failure to conduct a proper impact assessment directly contravenes regulatory requirements that mandate the consideration of data protection by design and by default, risks exposing sensitive data, leading to potential breaches and noncompliance penalties. Another incorrect approach is to assume that existing security measures are sufficient without a specific evaluation of how the new analytics platform interacts with them. This oversight can create new vulnerabilities or bypass existing controls, leaving data exposed. Regulations often require specific security safeguards for processing sensitive data, and a generic assumption of sufficiency is a regulatory and ethical failure. A third incorrect approach is to defer the privacy and security considerations to a later stage, such as after the system is in production. This reactive stance is a significant professional and regulatory failing. It demonstrates a lack of due diligence and can result in costly remediation efforts, legal liabilities, and damage to the organization's reputation, all of which could have been avoided with a timely impact assessment. Professional reasoning. Professionals should adopt a risk-based approach to impact assessment. This involves identifying potential threats and vulnerabilities related to data privacy and security, evaluating the likelihood and impact of these risks, and implementing appropriate controls to mitigate them. The decision-making process should be iterative, involving stakeholders from legal, compliance, and business units to ensure a holistic understanding of the implications. Prioritizing a privacy by design and security by design methodology ensures that compliance is embedded into the architecture from its inception, rather than being an afterthought. Question 5. Investigation of the potential for a large retail organization to leverage its vast customer transaction data for predictive analytics to identify at-risk customers for targeted retention campaigns, considering the architect's responsibilities under U.S. data privacy regulations. Option A. Conduct a comprehensive data protection impact assessment, DPIA, to identify and mitigate privacy risks associated with the collection, processing, and analysis of customer transaction data, ensuring compliance with relevant U.S. federal and state privacy laws before proceeding with the predictive analytics. Option B. Proceed with the development of the predictive analytics model using the raw transaction data, assuming that the insights gained will outweigh any potential privacy concerns, and address any privacy issues only if they arise. Option C. Implement basic data masking techniques on the transaction data, such as removing direct identifiers like names and addresses, and then proceed with the analytics, believing this is sufficient to protect customer privacy. Option D. Focus solely on the technical architecture and performance of the big data platform for the analytics, deferring any detailed privacy considerations to the marketing department responsible for campaign execution. The correct answer is A. Conduct a comprehensive data protection impact assessment (DPIA) to identify and mitigate privacy risks associated with the collection, processing, and analysis of customer transaction data, ensuring compliance with relevant U.S. federal and state privacy laws before proceeding with the predictive analytics. Explanation: this scenario presents a professional challenge due to the inherent tension between leveraging advanced analytics for business advantage and adhering to stringent data privacy regulations. The architect must balance the potential benefits of identifying customer churn patterns with the legal and ethical obligations to protect sensitive personal information. The complexity arises from the need to anonymize or pseudonymize data effectively without rendering it useless for analysis, and to ensure that any derived insights do not inadvertently lead to discriminatory practices or re-identification of individuals, which could violate data protection principles. The correct approach represents best professional practice because it prioritizes a privacy-by-design methodology. By conducting a thorough impact assessment that explicitly considers the IBM Big Data Architect's responsibilities under relevant data protection laws, e.g., GDPR if the exam context implies a US/EU intersection, or specific US federal/state laws if solely US focused. Assuming a U.S. context for this example, the architect ensures that potential risks to individual privacy are identified and mitigated before implementation. This proactive stance aligns with the principles of data minimization, purpose limitation, and accountability mandated by such regulations. It involves understanding the data lifecycle, identifying sensitive data elements, assessing the likelihood and severity of privacy breaches, and implementing appropriate technical and organizational measures, such as robust anonymization techniques and access controls. This demonstrates a commitment to ethical data handling and regulatory compliance, fostering trust with customers and avoiding legal repercussions. An incorrect approach that involves proceeding with the analysis without a formal impact assessment fails to uphold the duty of care required of a data architect. Constitutes a regulatory failure by potentially violating data protection laws that mandate risk assessments for processing personal data, especially when employing advanced analytics. Ethically, it demonstrates a disregard for individual privacy rights. Another incorrect approach, which relies solely on superficial data masking without a comprehensive understanding of re-identification risks, is also professionally unacceptable. This can lead to a false sense of security while still exposing individuals to privacy harm, a failure in due diligence, and a potential violation of regulations requiring effective anonymization. A third incorrect approach, focusing only on the technical feasibility of the analytics without considering the downstream impact on data subjects, ignores the broader ethical and legal implications, representing a significant oversight in professional responsibility. The professional reasoning process for similar situations should involve a structured, risk-based approach. First, clearly define the project's objectives and the data required. Second, identify all applicable regulatory frameworks and ethical guidelines. Third, conduct a comprehensive data protection impact assessment, DPIA or equivalent, scrutinizing data sources, processing activities, potential risks, and mitigation strategies. Fourth, engage with legal and compliance teams to ensure alignment with regulatory requirements. Fifth, implement technical and organizational safeguards throughout the data lifecycle. Finally, establish ongoing monitoring and review mechanisms to adapt to evolving risks and regulations. Question 6. What factors determine the scope and depth of an impact assessment for a new big data analytics initiative within an enterprise, considering technical, operational, security, and compliance dimensions? Option A, the novelty of the technology being introduced and the potential for cost savings in data storage. Option B, the number of developers involved in the project and the ease of integrating with existing reporting tools. Option C, the perceived urgency of delivering insights to stakeholders and the availability of existing infrastructure components. Option D, the criticality of the data being processed, the potential for regulatory noncompliance, the complexity of the proposed architecture, and the anticipated user base. The correct answer is D, the criticality of the data being processed, the potential for regulatory noncompliance, the complexity of the proposed architecture, and the anticipated user base. Explanation. Scenario analysis. This scenario presents a common challenge in big data architecture, balancing the need for rapid deployment of new analytical capabilities with the imperative to conduct thorough impact assessments. The pressure to deliver insights quickly can lead to shortcuts in evaluating potential consequences, which can have significant downstream effects on data integrity, system performance, regulatory compliance, and business operations. The challenge lies in identifying and prioritizing the most critical impact areas without unduly delaying essential business initiatives. Correct approach analysis. The correct approach involves a systematic evaluation of potential impacts across several key dimensions. This includes assessing the technical implications on existing infrastructure, data pipelines, and performance, the operational impact on users, processes, and support teams, the security implications, particularly concerning data access, privacy, and potential vulnerabilities, and the compliance implications, ensuring adherence to relevant data protection regulations and industry standards. This comprehensive approach ensures that potential risks are identified and mitigated proactively, aligning with best practices for responsible data governance and risk management. By considering these multifaceted impacts, architects can make informed decisions that safeguard the organization's data assets and operational integrity. Incorrect approaches analysis. Focusing solely on immediate technical feasibility without considering operational or security impacts is a significant regulatory and ethical failure. This oversight can lead to systems that are technically functional but impractical to manage, insecure, or prone to data breaches, violating data protection principles, and potentially leading to noncompliance with regulations like GDPR or CCPA, depending on the exam's specified jurisdiction, which for C2090-102 IBM Big Data Architect is generally assumed to be US-centric unless otherwise specified, thus referencing US data privacy laws. Prioritizing only cost reduction without a thorough impact assessment on data quality or system reliability is another failure. This can result in compromised data integrity, leading to flawed analytics and poor business decisions, and can also violate principles of data accuracy and trustworthiness mandated by data governance frameworks. Ignoring potential compliance issues until after deployment is a critical regulatory failure. This reactive approach can lead to significant fines, reputational damage, and loss of customer trust if data is handled in a manner that violates privacy laws or industry-specific regulations. It demonstrates a lack of due diligence and a disregard for legal and ethical obligations. Professional reasoning. Professionals should adopt a risk-based approach to impact assessment. This involves identifying potential impacts, evaluating their likelihood and severity, and prioritizing mitigation efforts based on the overall risk profile. A structured framework, such as a data governance policy that mandates impact assessments for all new data initiatives, should be followed. This framework should include clear criteria for what constitutes a significant impact and require sign-off from relevant stakeholders, including legal, compliance, and security teams, before proceeding with deployment. Continuous monitoring and reassessment of impacts post-deployment are also crucial for adaptive risk management. Question 7. When evaluating the implementation of a new big data analytics platform designed to derive predictive insights from customer transaction history and social media interactions, which approach best ensures adherence to data privacy principles and regulatory compliance? Option A. Perform a high-level review of the data sources to confirm they are publicly available, without delving into the specifics of how the data will be combined or analyzed. Option B. Focus primarily on the technical architecture and scalability of the platform to ensure efficient data ingestion and processing, assuming existing security protocols are sufficient. Option C. Prioritize the immediate delivery of business insights by fast-tracking the implementation, with a plan to address any potential compliance issues retrospectively. Option D. Conduct a comprehensive data protection impact assessment (DPIA) that scrutinizes data collection, processing, storage, and sharing mechanisms, identifying potential privacy risks and outlining mitigation strategies in alignment with relevant data protection laws. The correct answer is D. Conduct a comprehensive data protection impact assessment (DPIA) that scrutinizes data collection, processing, storage, and sharing mechanisms, identifying potential privacy risks and outlining mitigation strategies in alignment with relevant data protection laws. Explanation. This scenario presents a professional challenge because the organization is seeking to leverage advanced analytics on sensitive customer data without a clear understanding of the potential downstream impacts on data privacy, security, and regulatory compliance. The architect must balance the business imperative for data-driven insights with the ethical and legal obligations to protect individuals' information. A robust impact assessment is crucial to proactively identify and mitigate risks before significant investment or implementation occurs. The correct approach represents best professional practice because it systematically evaluates the potential consequences of the proposed big data initiative. This involves identifying all relevant data sources, understanding the nature of the data, especially if it includes personally identifiable information or sensitive attributes, assessing the proposed analytical techniques, and considering the potential for unintended data exposure or misuse. This proactive risk identification aligns with principles of data minimization, purpose limitation, and accountability, which are foundational to many data protection regulations. By conducting a thorough impact assessment, the architect ensures that the project adheres to legal requirements, ethical standards, and organizational policies, thereby building trust with customers and stakeholders. An incorrect approach that focuses solely on the technical feasibility of ingesting and processing the data fails to consider the broader implications. This oversight can lead to regulatory violations, such as breaches of data privacy laws. By processing data without adequate consent or for purposes not originally disclosed. Ethically, it demonstrates a disregard for customer privacy and can result in reputational damage. Another incorrect approach that prioritizes immediate business value without a comprehensive risk evaluation is also professionally unacceptable. This can result in the deployment of systems that inadvertently expose sensitive data, leading to significant financial penalties and legal liabilities. It also undermines the principle of responsible innovation, where technological advancement must be tempered by a consideration of its societal and individual impacts. A third incorrect approach that relies on a superficial review of existing security measures without a specific assessment of the new big data context is inadequate. Existing measures may not be sufficient to address the unique vulnerabilities introduced by large-scale data aggregation and advanced analytics. This can lead to security breaches and non-compliance with data protection mandates that require specific safeguards for large datasets. The professional reasoning process for similar situations should involve a structured impact assessment framework. This framework should include steps for data inventory and classification, risk identification and analysis, including privacy, security and compliance risks, mitigation strategy development, and ongoing monitoring. Professionals should engage with legal, compliance, and security teams early in the process and maintain a clear audit trail of decisions and assessments. The goal is to embed a culture of responsible data stewardship throughout the data lifecycle. Question 8. The control framework reveals that a new big data analytics platform is being considered for deployment to derive insights from customer interaction data. Before proceeding with the implementation, what is the most critical step to ensure compliance with data governance and privacy regulations? Option A. Obtain legal counsel only after the platform has been fully implemented and is in production. Option B. Conduct a comprehensive data impact assessment to identify potential regulatory and privacy risks associated with the proposed platform and its data processing activities. Option C. Proceed with the implementation and address any compliance issues that arise during or after deployment. Option D. Focus solely on the technical performance and scalability of the big data platform. The correct answer is B. Conduct a comprehensive data impact assessment to identify potential regulatory and privacy risks associated with the proposed platform and its data processing activities. Explanation. This scenario presents a professional challenge because the organization is attempting to implement a new big data solution without a thorough understanding of its potential downstream impacts on existing regulatory compliance obligations. The core difficulty lies in balancing the drive for innovation and data utilization with the imperative to adhere to data privacy, security, and governance regulations. A hasty implementation without a proper impact assessment risks not only non-compliance, but also potential data breaches, reputational damage, and significant financial penalties. Careful judgment is required to ensure that the technological advancement is aligned with, rather than in conflict with, the established legal and ethical landscape. The correct approach represents best professional practice because it prioritizes a proactive and systematic evaluation of the proposed big data solution against all relevant regulatory requirements. This aligns with the principles of data governance and responsible innovation. Specifically, it ensures that the organization can identify potential compliance gaps early in the project lifecycle, allowing for mitigation strategies to be integrated into the design and implementation phases. This approach is ethically sound as it demonstrates a commitment to protecting individual privacy and data security, and it is legally prudent by minimizing the risk of regulatory violations. An incorrect approach that fails to conduct a comprehensive impact assessment before implementation is professionally unacceptable due to several regulatory and ethical failures. Firstly, it violates the principle of privacy by design and security by design, which are fundamental to many data protection regulations. By not assessing impacts upfront, the organization is essentially building a system that may inherently be non-compliant, leading to potential breaches of data privacy laws. Secondly, it demonstrates a disregard for data governance frameworks, which mandate understanding data flows, usage, and associated risks. This can lead to unauthorized data access or processing, contravening data protection principles, and potentially violating specific articles within data privacy legislation. Ethically, it shows a lack of due diligence in safeguarding sensitive information, which can erode trust with data subjects and stakeholders. The professional reasoning process for similar situations should involve a structured approach to risk management and compliance. This begins with clearly defining the scope and objectives of the Big Data Initiative. Subsequently, a thorough inventory of all applicable regulations e.g., GDPR, CCPA, HIPAA, depending on the jurisdiction, must be compiled. A detailed impact assessment should then be conducted, mapping the proposed data flows, processing activities, and storage mechanisms against each regulatory requirement. This assessment should identify potential risks, vulnerabilities, and areas of non-compliance. Based on the findings, mitigation strategies, including technical controls, policy updates, and training, should be developed and integrated into the project plan. Continuous monitoring and auditing post-implementation are also crucial to ensure ongoing compliance. Question 9. Risk assessment procedures indicate that a proposed big data solution for customer behavior analysis may inadvertently expose sensitive personal information if not architected with robust data protection measures. The organization aims to derive actionable insights from large volumes of transactional and interaction data. Which architectural approach best balances the need for analytical insights with the imperative to protect customer privacy and comply with data protection regulations? Option A. Implement advanced anonymization and pseudonymization techniques, differential privacy where applicable, and granular access controls, integrated from the initial design phase with a comprehensive data governance framework. Option B. Rely on the assumption that the sheer volume of data will inherently obscure individual identities, negating the need for explicit privacy controls during the initial architecture. Option C. Proceed with data ingestion and analysis, assuming that removing direct identifiers is sufficient for anonymization, and address privacy concerns only if a specific compliance issue arises. Option D. Focus primarily on the analytical capabilities of the big data platform, deferring detailed privacy and security control implementation to a later stage of the project lifecycle. Correct answer is A. Implement advanced anonymization and pseudonymization techniques, differential privacy where applicable, and granular access controls, integrated from the initial design phase with a comprehensive data governance framework. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent tension between leveraging advanced analytics for business advantage and the imperative to protect sensitive customer data. The architect must balance the potential for deep insights from big data with the legal and ethical obligations to maintain data privacy and security. The complexity arises from the distributed nature of big data, the variety of data sources, and the potential for re-identification even with anonymized data, all within a regulated environment. Careful judgment is required to ensure that the proposed big data solution not only meets business objectives, but also adhere strictly to data protection principles and regulations. Correct approach analysis. The correct approach emphasizes a privacy-by-design methodology, integrating data protection considerations from the outset of the big data solution architecture. This involves implementing robust anonymization and pseudonymization techniques, employing differential privacy where appropriate, and establishing strict access controls and data governance policies. This aligns with the principles of data minimization and purpose limitation, which are cornerstones of data protection regulations. By proactively embedding privacy controls, the architect demonstrates a commitment to responsible data handling, mitigating the risk of breaches and ensuring compliance with legal requirements, thereby fostering customer trust and avoiding significant regulatory penalties. Incorrect approaches analysis. An approach that prioritizes immediate data ingestion and analysis without a comprehensive privacy impact assessment and the implementation of appropriate anonymization techniques fails to meet regulatory obligations. This could lead to the inadvertent exposure of personally identifiable information, PI, violating data protection laws and potentially resulting in severe fines and reputational damage. Another incorrect approach would be to rely solely on the assumption that data is rendered anonymous by simply removing direct identifiers, without considering the possibility of re-identification through sophisticated analytical techniques or by combining datasets. This oversight neglects the evolving landscape of data analytics and the potential for indirect identification, which is a critical concern under data protection frameworks. Finally, an approach that delays the implementation of security and privacy controls until after the data has been collected and analyzed is reactive rather than proactive. This significantly increases the risk of data breaches and noncompliance, as sensitive data may have already been exposed or mishandled during the initial stages of the project. Professional reasoning. Professionals should adopt a risk-based approach to big data architecture, integrating privacy and security considerations as fundamental design principles. This involves conducting thorough data protection impact assessments, understanding the specific regulatory landscape applicable to the data being processed, and implementing a layered security model. Decision-making should be guided by a commitment to ethical data stewardship, ensuring that the pursuit of business insights never compromises individual privacy rights. Continuous monitoring and adaptation of privacy controls are essential as data analytics capabilities and regulatory expectations evolve. Question 10. The assessment process reveals that a new big data initiative requires ingesting and processing vast amounts of sensitive customer data from multiple disparate sources. The primary business objective is to derive real-time insights for personalized marketing campaigns. However, the organization is subject to strict data privacy regulations that mandate clear audit trails for data access and transformation, as well as robust data lineage tracking. The architect must design a solution that balances the need for rapid data availability with comprehensive compliance. Which of the following architectural approaches best addresses these competing requirements while adhering to best practices for data governance and regulatory compliance? Option A. Implement a data lakehouse architecture with integrated metadata management, robust access control policies, and automated data lineage tracking capabilities, ensuring all data transformations are logged and auditable. Option B. Prioritize maximum data ingestion speed by using a raw data dump into a distributed file system, with a plan to address governance and auditability requirements in a subsequent phase. Option C. Utilize a streaming ingestion pipeline that directly feeds data into a real-time analytics engine, bypassing intermediate storage or transformation logging to minimize latency. Option D. Deploy a traditional relational database system for all sensitive data, accepting potential performance limitation to ensure immediate compliance with existing data governance frameworks. The correct answer is A. Implement a data lakehouse architecture with integrated metadata management, robust access control policies, and automated data lineage tracking capabilities, ensuring all data transformations are logged and auditable. Explanation. The assessment process reveals a common challenge in big data architecture, balancing the need for rapid data ingestion and processing with the imperative to maintain data integrity and adhere to evolving regulatory requirements. In the context of IBM Big Data Architect certification, this scenario is professionally challenging because it demands a nuanced understanding of how architectural choices impact compliance, security, and the overall trustworthiness of the data. The architect must not only design for performance and scalability, but also proactively embed mechanisms for auditability and regulatory adherence, which can sometimes appear to conflict with speed. The correct approach represents best professional practice because it prioritizes a robust, auditable data lineage and governance framework from the outset. This aligns with the principles of data stewardship and accountability, which are increasingly codified in regulatory frameworks. By implementing a solution that includes comprehensive logging, metadata management, and access controls, the architect ensures that the data's journey from source to insight is transparent and verifiable. This transparency is crucial for demonstrating compliance with data protection regulations, such as those requiring the ability to track data usage, identify data owners, and ensure data quality. It fosters trust among stakeholders and mitigates risks associated with data breaches or misuse. An incorrect approach that focuses solely on maximizing ingestion speed without adequate governance mechanisms fails to meet regulatory obligations. For instance, neglecting to log data transformations or access events creates blind spots, making it impossible to audit data usage or prove compliance with data privacy laws. This can lead to significant penalties, reputational damage, and loss of customer trust. Another incorrect approach might involve implementing security controls that are overly restrictive, hindering legitimate data access and analysis, which can indirectly impact business operations and potentially violate principles of data availability where applicable. Furthermore, a reactive approach to governance, where compliance measures are bolted on after the architecture is in place, is inherently inefficient and prone to oversight, increasing the likelihood of regulatory noncompliance. Professional reasoning in such situations requires a proactive, risk-based approach. Architects should begin by thoroughly understanding the relevant regulatory landscape and the specific data governance requirements. They should then integrate these requirements into the core design principles, rather than treating them as an afterthought. This involves continuous evaluation of architectural components for their compliance implications, engaging with legal and compliance teams early in the design process, and prioritizing solutions that offer built-in auditability and governance features. The decision-making process should weigh performance gains against compliance risks, always erring on the side of caution when regulatory adherence is at stake. Question 11. Risk assessment procedures indicate that a large retail organization plans to leverage its extensive customer transaction history for advanced predictive analytics to personalize marketing campaigns. The data includes purchase details, browsing behavior, and demographic information. The primary concern is ensuring that customer privacy is maintained throughout the data lifecycle, from ingestion to analysis and reporting. In compliance with U.S. data protection frameworks, which of the following architectural approaches best balances the need for actionable insights with robust data privacy protection? Option A. Implement robust role-based access controls and encryption for the entire customer data lake, allowing direct analysis of raw transaction data by authorized marketing analysts. Option B. Obtain a single, broad consent from all customers for the use of their data in any future analytical endeavors, without specifying the exact nature of the analysis or data types involved. Option C. Anonymize or pseudonymize customer identifiable information at the point of data ingestion, creating separate, aggregated datasets for analytical purposes, and then apply advanced analytics. Option D. Collect and store all raw customer transaction data without any modifications, relying solely on a strict data retention policy to purge data after a predefined period. The correct answer is A. Implement robust role-based access controls and encryption for the entire customer data lake, allowing direct analysis of raw transaction data by authorized marketing analysts. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent tension between leveraging advanced analytics for business advantage and the imperative to protect sensitive customer data. The architect must navigate the complexities of data privacy regulations, which are increasingly stringent, while also enabling data-driven decision-making. The challenge lies in finding a balance that is both compliant and strategically beneficial, requiring a deep understanding of both technical capabilities and legal obligations. The potential for reputational damage and significant financial penalties for non-compliance necessitates a rigorous and well-informed approach. Correct approach analysis. The correct approach prioritizes data anonymization and pseudonymization techniques before data aggregation and analysis. This aligns with the principles of data minimization and purpose limitation, fundamental tenets of data privacy regulations such as the General Data Protection Regulation, GDPR, if this were a US-based exam, or similar US frameworks, by transforming personally identifiable information, PI, into non-identifiable or indirectly identifiable data, the organization significantly reduces the risk of data breaches, exposing sensitive customer details. This proactive measure ensures that the analytical insights derived are valuable without compromising individual privacy rights, representing best professional practice by embedding privacy by design and by default. Incorrect approach is analysis, an approach that focuses solely on technical controls like access management, without addressing the inherent sensitivity of the data itself, fails to meet regulatory requirements for data protection. While access controls are important, they do not prevent the exposure of PII if the data is not adequately protected at its source or during processing. This approach risks regulatory violations by not implementing sufficient technical and organizational measures to ensure data privacy. Another incorrect approach that involves analyzing raw, unanonymized customer data, even with the intention of aggregating it later, poses a significant privacy risk. This directly contravenes data minimization principles and increases the likelihood of accidental disclosure or misuse of sensitive information. Such a practice would be a clear violation of data protection laws, leading to severe penalties. Finally, an approach that relies on obtaining broad, nonspecific consent for all future data analysis without clearly outlining the types of data and the intended analytical purposes is ethically questionable and likely legally insufficient. Modern data privacy regulations emphasize granular consent and transparency, requiring individuals to be informed about how their data will be used. This approach fails to provide the necessary transparency and control to individuals, risking noncompliance. Professional reasoning. Professionals in this field must adopt a risk-based approach to data architecture. This involves identifying potential data privacy risks early in the design phase and implementing controls to mitigate them. A robust decision-making process includes 1. Understanding the specific data privacy regulations applicable to the organization's operating jurisdiction. 2. Conducting a thorough data inventory and classification to identify sensitive data. 3. Evaluating analytical requirements against privacy obligations. 4. Designing and implementing technical and organizational measures that embed privacy by design. 5. Regularly reviewing and updating data protection strategies in response to evolving threats and regulatory changes. This systematic approach ensures that data is handled responsibly, ethically, and in compliance with all relevant laws. Question 12. Operational review demonstrates that a large retail organization is experiencing an increasing rate of customer churn. To proactively address this, the data architecture team is tasked with building a predictive model to identify customers at high risk of churning. The proposed solution involves analyzing granular customer transaction history, including purchase details, browsing behavior on the website, and customer service interaction logs, all of which contain personally identifiable information (PI). The organization operates under a regulatory framework that mandates strong data privacy protections for customer data. Which of the following approaches best balances the business need for predictive analytics with regulatory compliance and ethical data handling? Option A. Anonymize and aggregate customer transaction data to identify behavioral patterns and trends associated with churn, without using individual customer identifiers in the analytical models. Option B. Obtain explicit granular consent from each customer for the use of their specific transaction details, browsing history, and interaction logs for churn prediction analysis. Option C. Analyze raw customer transaction data directly, ensuring it is stored in a separate, highly secured data lake with strict access controls for the analytical team. Option D. Implement a data anonymization process, but retain the ability to re-identify individuals if a specific customer's churn risk needs to be investigated further by customer service. Correct answer is A. Anonymize and aggregate customer transaction data to identify behavioral patterns and trends associated with churn, without using individual customer identifiers in the analytical models. Explanation. This scenario presents a professional challenge due to the inherent tension between leveraging advanced analytics for business advantage and ensuring compliance with data privacy regulations. Architect must balance the potential benefits of identifying customer churn patterns with the ethical and legal obligation to protect sensitive personal information. Careful judgment is required to implement solutions that are both effective and compliant. The correct approach represents best professional practice because it prioritizes data anonymization and aggregation before analysis. This aligns with the principles of data minimization and purpose limitation, fundamental tenets of data privacy regulations. By removing or obscuring personally identifiable information, PI, the organization significantly reduces the risk of a data breach exposing sensitive customer details. This proactive measure demonstrates a commitment to responsible data stewardship and builds trust with customers. Furthermore, anonymized data can still yield valuable insights into aggregate behavior, fulfilling the business objective without compromising individual privacy. An incorrect approach that involves direct analysis of raw customer transaction data without anonymization or aggregation poses significant regulatory and ethical failures. This directly violates principles of data privacy by exposing PII to potential compromise during the analytical process. If a breach were to occur, the organization would face severe penalties under data protection laws, including substantial fines and reputational damage. Ethically, it demonstrates a disregard for customer privacy and a lack of due diligence in safeguarding sensitive information. Another incorrect approach, which involves obtaining explicit consent for every granular data point used in the churn analysis, is often impractical and may not fully address the spirit of data protection. While consent is a cornerstone of data privacy, overly broad or granular consent requests can be burdensome for customers and may not be truly informed. Moreover, relying solely on consent without implementing technical safeguards like anonymization can still leave data vulnerable. The regulatory failure lies in potentially not adequately protecting data even with consent, as the primary obligation is to secure the data itself. A third incorrect approach, which involves storing all raw customer data in a separate, highly secured data lake but performing analysis directly on this raw data, still carries inherent risks. While security measures are important, the mere presence of raw PII within an analytical environment increases the attack surface and the potential impact of a breach. The regulatory failure here is that the focus is on securing the data at rest, rather than minimizing its exposure during processing. Best practice dictates minimizing the use of raw PII in analytical workflows wherever possible. The professional decision-making process for similar situations should involve a risk-based approach. First, clearly define the business objective and the data required to achieve it. Second, identify all potential PII within the data. Third, explore and implement data minimization techniques, such as anonymization and aggregation, to reduce the sensitivity of the data used for analysis. Fourth, if raw PII is absolutely necessary, ensure robust security controls and access management are in place, and consider obtaining informed consent where appropriate and feasible. Finally, regularly review and audit data handling processes to ensure ongoing compliance and ethical data practices. Question 13. The audit findings indicate that the data used for the recent customer churn prediction model exhibits inconsistencies in its historical accuracy and a lack of clear documentation regarding its transformation processes. The business unit is pushing for rapid deployment of the model to inform retention strategies. Which of the following approaches best addresses the audit findings while ensuring the integrity and reliability of the predictive analytics? Option A. Implement automated data lineage tracking from source systems through all transformation stages to the model, coupled with automated data quality validation rules at key points in the data pipeline. Option B. Focus solely on refining the predictive model's algorithms to compensate for potential data inaccuracies, assuming that advanced modeling techniques can overcome inherent data quality issues. Option C. Conduct a one-time manual review of a sample of the historical data to identify major anomalies and proceed with model deployment, deferring further data quality improvements to a later phase. Option D. Accept the current data quality and transformation documentation as sufficient for initial deployment, with a plan to address any issues that arise post-deployment based on model performance feedback. The correct answer is A. Implement automated data lineage tracking from source systems through all transformation stages to the model, coupled with automated data quality validation rules at key points in the data pipeline. Explanation: the audit findings indicate a potential breach of data governance principles, specifically concerning the lineage and quality of data used in critical business analytics. This scenario is professionally challenging because it requires the architect to balance the immediate need for actionable insights with the long-term imperative of maintaining data integrity and regulatory compliance. The pressure to deliver business value can sometimes lead to shortcuts that compromise data quality and traceability, creating significant risks. The correct approach, focusing on establishing robust data lineage tracking and implementing automated data quality checks at ingestion and transformation stages, represents best professional practice. This aligns with the principles of data governance, which emphasize transparency, accountability, and reliability. By ensuring that the origin, transformations, and quality of data are meticulously documented and validated, the architect builds trust in the analytical outputs and mitigates risks associated with inaccurate or misleading insights. This proactive stance is crucial for meeting regulatory expectations regarding data accuracy and auditability. Even if specific regulations are not explicitly detailed in the exam syllabus, the underlying principles of responsible data management are universally applicable. An incorrect approach that involves relying solely on manual data validation and ad hoc quality checks is professionally unacceptable. This method is prone to human error, inconsistency, and is not scalable. It fails to provide an auditable trail of data quality, making it difficult to identify and rectify issues, and potentially leading to regulatory noncompliance if data accuracy is a mandated requirement. Another incorrect approach, which prioritizes speed of delivery over data quality by accepting data with known anomalies, poses a significant ethical and professional risk. This can lead to flawed business decisions, reputational damage, and potential legal repercussions if the flawed data impacts customers or stakeholders. It demonstrates a disregard for the fundamental responsibility of an architect to ensure the integrity of the systems and data they manage. The professional decision-making process for similar situations should involve a risk-based assessment. Architects must first identify the critical data elements and analytical processes that have the highest impact on business operations and regulatory compliance. They should then prioritize the implementation of data governance controls, including lineage tracking and automated quality checks, based on these identified risks. Continuous monitoring and periodic reevaluation of data governance strategies are essential to adapt to evolving business needs and regulatory landscapes. Collaboration with data stewards, business stakeholders, and compliance officers is vital to ensure a holistic and effective approach to data management. Question 14. Stakeholder feedback indicates a critical need for near real-time business intelligence derived from a rapidly growing volume of diverse data sources, including customer transaction logs, social media sentiment, and EOT sensor readings. Simultaneously, the organization faces increasing scrutiny regarding data privacy and auditability, particularly concerning customer data and financial transactions, necessitating strict adherence to U.S. regulatory frameworks such as SOX and HIPAA. The proposed big data architecture must therefore enable rapid data processing and analysis, while ensuring complete transparency and traceability of data from ingestion to consumption. Which architectural approach best balances the immediate business demand for real-time insights with the stringent regulatory requirements for data governance and auditability in this U.S.-regulated environment? Option A. Focus on ingesting and processing all data into a high-performance data warehouse using traditional ETL processes, prioritizing data quality checks over real-time accessibility. Option B. Utilize a federated data access layer that queries disparate data sources directly for analytics, without centralizing data or implementing comprehensive lineage tracking. Option C. Deploy a distributed in-memory processing engine for all data, with a primary focus on speed, and implement manual data validation checks post-processing to ensure compliance. Option D. Implement a data lakehouse architecture with robust data lineage tracking capabilities integrated from the outset, enabling both real-time streaming analytics and auditable historical data analysis. The correct answer is D. Implement a data lakehouse architecture with robust data lineage tracking capabilities integrated from the outset, enabling both real-time streaming analytics and auditable historical data analysis. Explanation: scenario analysis. This scenario presents a common challenge in big data architecture, where the need for real-time analytics clashes with data governance requirements. The professional challenge lies in balancing the immediate business demand for insights with the imperative to maintain data integrity, security, and compliance. Failure to do so can lead to inaccurate decision-making, regulatory penalties, and erosion of stakeholder trust. Careful judgment is required to select an architectural approach that is both performant and compliant. Correct approach analysis. Implementing a robust data lineage tracking mechanism within the data lake architecture is the best professional practice. This approach directly addresses the need for auditability and compliance by ensuring that the origin, transformations, and movement of data are meticulously recorded. In the context of U.S. regulations like SOX, Sarbanes-Oxley Act, and HIPAA, Health Insurance Portability and Accountability Act, maintaining accurate and auditable financial and health data records is paramount. Data lineage provides the necessary transparency to demonstrate compliance, identify data quality issues, and support forensic analysis if required. It aligns with the principle of data stewardship and responsible data management, ensuring that data used for critical business decisions is trustworthy and its provenance is understood. Incorrect approaches analysis. An approach that prioritizes immediate data ingestion and processing without establishing clear data governance policies and lineage tracking mechanisms poses significant regulatory and ethical risks. For instance, under SOX, financial reporting relies on the accuracy and integrity of data. Without lineage, it becomes impossible to trace the source of any discrepancies or to prove the validity of financial reports, leading to potential violations and severe penalties. Ethically, this approach demonstrates a disregard for data quality and accountability. Another incorrect approach would be to implement a rigid, batch-oriented ETL process that cannot support the real-time analytics requirement. While this might offer some level of control, it fails to meet the business need for timely insights, rendering the big data initiative ineffective. From a regulatory perspective, while not directly a violation, it represents a failure to leverage technology effectively to meet business objectives, which can indirectly impact competitive standing and operational efficiency, potentially leading to other compliance-related issues if business performance suffers. Ethically, it represents a missed opportunity to provide valuable business intelligence. Finally, an approach that relies solely on manual data validation and reconciliation after ingestion, without automated lineage tracking, is prone to human error and is not scalable for big data volumes. This significantly increases the risk of undetected data quality issues and compliance breaches. For example, in healthcare, incorrect patient data due to manual errors can have life-threatening consequences and violate HIPAA data integrity requirements. Ethically, it places an undue burden on personnel and increases the likelihood of mistakes that could harm individuals or the organization. Professional reasoning. Professionals should adopt a risk-based approach, prioritizing solutions that demonstrably meet both business objectives and regulatory mandates. This involves understanding the specific data governance and compliance requirements relevant to the industry and jurisdiction. In this case, U.S. regulations. The decision-making process should involve 1. Identifying critical data elements and their regulatory implications. 2. Evaluating architectural patterns for their ability to support real-time processing while ensuring data integrity and auditability. 3. Incorporating data governance and lineage as foundational components, not afterthoughts. And 4. Conducting thorough risk assessments to understand the potential impact of architectural choices on compliance and business outcomes. Question 15. Quality control measures reveal a consistent pattern of minor data discrepancies and occasional missing values in the raw data streams being ingested into the enterprise data lake. These discrepancies, while not immediately catastrophic, could lead to skewed analytical results and potential compliance issues if left unaddressed. The business stakeholders are pushing for faster ingestion to enable near real-time analytics. As the big data architect, what is the most appropriate strategy to address these data quality concerns while supporting the business's need for speed? Option A. Implement automated data profiling and anomaly detection at the point of ingestion, coupled with robust data lineage tracking and role-based access controls for downstream consumption. Option B. Skip data lineage tracking for the initial raw data ingestion, relying on transformations to capture lineage later in the data processing pipeline. Option C. Institute a manual review process for every incoming data record to ensure absolute accuracy before it is allowed into the data lake. Option D. Postpone all data quality checks until after the data has been loaded into the data warehouse, focusing solely on optimizing the ingestion process for maximum speed. Correct answer is A. Implement automated data profiling and anomaly detection at the point of ingestion, coupled with robust data lineage tracking and role-based access controls for downstream consumption. Explanation. Scenario analysis. This scenario presents a professional challenge stemming from the inherent tension between rapid data ingestion for real-time analytics and the need for robust data governance and compliance. The challenge lies in balancing the business imperative for immediate insights with the regulatory requirements for data accuracy, lineage, and security. A data architect must navigate this by implementing controls that do not unduly impede performance while ensuring adherence to established frameworks. The need for careful judgment arises from the potential for misinterpreting or over-applying controls, leading to either compliance breaches or operational inefficiencies. Correct approach analysis. The correct approach involves implementing a multi-layered data validation strategy that integrates checks at various stages of the data pipeline, from ingestion to consumption. This aligns with best practices for data quality and regulatory compliance. Specifically, it emphasizes automated data profiling and anomaly detection during ingestion to flag potential issues early. It also mandates comprehensive data lineage tracking, which is crucial for auditability and compliance with regulations like GDPR, if applicable to the exam's assumed jurisdiction, which is U.S. for C2090-102, or similar data privacy laws that require understanding data flow and transformation. Furthermore, it advocates for role-based access controls and encryption to protect sensitive data, addressing security and privacy mandates. This approach represents best professional practice because it proactively addresses data integrity and security concerns without creating a bottleneck. It demonstrates a commitment to building a trustworthy data ecosystem, which is a core responsibility of a data architect. The focus on automated checks and lineage ensures that the organization can demonstrate compliance and respond effectively to data-related incidents, minimizing legal and reputational risks. Incorrect approaches analysis. One incorrect approach is to solely rely on post-processing data cleansing after the data has been loaded into the data warehouse. This is professionally unacceptable because it represents a reactive rather than proactive stance. It fails to address potential data quality issues at the source, increasing the risk of inaccurate analytics and flawed business decisions. From a regulatory perspective, it makes demonstrating data accuracy and integrity difficult, as the initial loaded data may have already violated compliance standards. It also increases the cost and complexity of remediation. Another incorrect approach is to implement stringent, manual data validation checks for every single data point before it enters the data lake. This is professionally unacceptable due to its severe impact on performance and scalability, which are core tenets of big data architecture. Such an approach would create a significant bottleneck, negating the benefits of a big data platform. Ethically and regulatorily, while aiming for accuracy, it fails to consider the practical implications and the principle of proportionality. It could also lead to data loss if the manual process cannot keep up with the ingestion rate, potentially violating data availability requirements. A third incorrect approach is to bypass data lineage tracking for raw ingested data, assuming it will be captured later in the transformation process. This is professionally unacceptable as it creates blind spots in data governance. Without lineage from the point of ingestion, it becomes impossible to trace the origin of data errors or security breaches, which is a critical requirement for many regulatory frameworks. This failure to maintain complete data lineage undermines auditability and accountability, exposing the organization to significant compliance risks. Professional reasoning. Professionals should adopt a risk-based, layered approach to data quality and governance. The decision-making process should involve understanding the specific regulatory landscape relevant to the data being handled, assessing the business impact of data inaccuracies, and evaluating the technical feasibility of various control mechanisms. Prioritize controls that offer the greatest impact in terms of risk reduction and compliance assurance with minimal performance degradation. Continuous monitoring and iterative refinement of data governance policies are essential. Always consider the principle of least privilege for data access and the importance of comprehensive data lineage for transparency and accountability. Question 16. The efficiency study reveals that the current batch processing of customer interaction data is causing a significant delay in identifying fraudulent transactions, potentially exposing the organization to financial losses and regulatory noncompliance. Which architectural shift would best address this latency issue while adhering to data governance principles? Option A. Increasing the frequency of existing batch processing jobs to run more often throughout the day. Option B. Implementing a real-time streaming data pipeline with robust message queuing and stream processing capabilities. Option C. Migrating the data processing to a cloud-based service without assessing its compliance certifications. Option D. Replicating the existing batch processing infrastructure on a separate, less powerful set of servers to reduce costs. Correct answer is B. Implementing a real-time streaming data pipeline with robust message queuing and stream processing capabilities. Explanation. The efficiency study reveals that the current data ingestion pipeline for customer transaction data is experiencing significant latency, impacting real-time analytics and fraud detection capabilities. This scenario is professionally challenging because it directly affects business operations and regulatory compliance. The latency could lead to missed fraud opportunities, delayed customer insights, and potential breaches of data privacy regulations if sensitive information is not processed within stipulated timeframes. Careful judgment is required to select a solution that not only improves efficiency, but also adheres to data governance and security standards. The correct approach involves implementing a streaming data architecture using technologies like Apache Kafka for message queuing and Apache Spark Streaming for real-time processing. This represents best professional practice because it directly addresses the latency issue by enabling continuous data flow and immediate processing. From a regulatory perspective, this approach facilitates compliance with data processing timelines often mandated by financial regulations, e.g., for fraud detection, and data privacy laws, e.g., for timely data subject requests. It ensures data is processed as close to real time as possible, minimizing risk and maximizing the value derived from the data. An incorrect approach would be to simply increase the batch processing frequency without fundamentally changing the architecture. This fails to address the core latency problem and may only offer marginal improvements, potentially increasing operational costs without achieving the desired real-time capabilities. Ethically, this approach might be seen as a superficial fix that doesn't fully meet the business's stated needs for real-time analytics, potentially misleading stakeholders about the system's true performance. Another incorrect approach would be to offload processing to a less secure or less compliant third-party service without proper due diligence. This poses significant regulatory risks, particularly concerning data privacy and security. If the third-party service does not adhere to the same stringent data protection standards, it could lead to data breaches, non-compliance with regulations like GDPR or CCPA, if applicable to the jurisdiction, and severe reputational damage. A third incorrect approach would be to prioritize cost savings over performance and security by selecting a technology stack that is not designed for high-throughput, low-latency streaming. This could lead to recurring performance issues, increased maintenance overhead, and ultimately, a failure to meet business objectives, potentially resulting in regulatory scrutiny for failing to maintain adequate data processing systems. The professional decision-making process for similar situations should involve a thorough assessment of business requirements, including performance SLAs and regulatory obligations. It should then involve evaluating potential technical solutions against these requirements, considering not only efficiency, but also scalability, security, and compliance. A proof of concept or pilot phase is often advisable to validate the chosen solution before full-scale implementation. Continuous monitoring and adaptation are also crucial to ensure ongoing compliance and performance. Question 17. Market research demonstrates that a rapidly growing startup is experiencing an exponential increase in diverse data sources, including unstructured text, sensor logs, and transactional records. The primary business objective is to gain immediate insights into customer behavior to inform product development and marketing campaigns. The data architecture team is tasked with designing a data ingestion strategy for a new big data platform. The challenge is to balance the urgency of insight generation with the need for robust data governance and compliance with potential future regulatory requirements concerning data accuracy and lineage. Which of the following data ingestion approaches best aligns with both the immediate business need for insights and the long-term imperative for data integrity and regulatory compliance? Option A. Focus solely on ingesting structured data from known sources, postponing the integration of unstructured and semi-structured data until a dedicated data quality framework is fully developed and implemented. Option B. Adopt a schema-on-read approach for all incoming data, deferring any structural or quality checks until the data is queried for specific analytical purposes. Option C. Prioritize ingesting all raw data at maximum velocity directly into the data lake, with the assumption that data cleansing and validation will be performed as a separate, subsequent data preparation phase. Option D. Implement a multi-stage ingestion pipeline that includes initial data profiling and validation at the edge, followed by a staged loading process into the data lake with comprehensive metadata capture and lineage tracking. Correct answer is D. Implement a multi-stage ingestion pipeline that includes initial data profiling and validation at the edge, followed by a staged loading process into the data lake with comprehensive metadata capture and lineage tracking. Explanation. Scenario analysis. This scenario presents a professional challenge in balancing the need for rapid data ingestion and analysis with the imperative to maintain data integrity and comply with evolving regulatory requirements for data governance. The architect must make a judgment call on the most appropriate data ingestion strategy, considering not only technical performance, but also the legal and ethical implications of data handling, particularly in the context of potential future regulatory scrutiny. The challenge lies in anticipating and mitigating risks associated with data quality and compliance before they manifest as operational issues or regulatory breaches. Correct approach analysis. The correct approach emphasizes a phased ingestion strategy with robust validation and lineage tracking. This aligns with best practices in data architecture and is implicitly supported by regulatory frameworks that mandate data accuracy, auditability, and accountability. For instance, in the U.S., regulations like the Health Insurance Portability and Accountability Act, HIPAA for healthcare data, or the Gramm-Leach-Bliley Act, GLBA, for financial data, while not directly dictating ingestion methods, necessitate that data used for decision-making is accurate, secure, and traceable. A phased approach allows for iterative refinement of data quality checks and ensures that data lineage is meticulously maintained, providing an auditable trail crucial for compliance and dispute resolution. This proactive stance on data governance minimizes the risk of introducing dirty data into the system, which could lead to flawed analytics, incorrect business decisions, and potential regulatory penalties. Incorrect approach is analysis, an approach that prioritizes immediate, high-volume ingestion without intermediate validation mechanisms introduces significant regulatory and ethical risks. Such a strategy could lead to the propagation of inaccurate or incomplete data, violating principles of data integrity that underpin many data protection and privacy regulations. For example, if sensitive personal data is ingested without proper anonymization or pseudonymization, it could violate regulations like the California Consumer Privacy Act, CCPA, or GDPR, if applicable to the data's origin. Though for this exam, we focus on U.S. This lack of control over data quality can also lead to biased analytics, which, depending on the application, could have discriminatory outcomes, raising ethical concerns and potentially violating anti-discrimination laws. Another incorrect approach might involve relying solely on downstream processing for data cleansing. This is professionally unsound because it delays the identification and remediation of data quality issues, increasing the cost and complexity of correction. Ethically, it represents a failure to exercise due diligence in data handling. From a regulatory perspective, it can lead to a situation where non-compliant data is already deeply embedded in the system, making remediation difficult and potentially exposing the organization to penalties for noncompliance with data accuracy requirements. A third incorrect approach could be to adopt a move fast and break things mentality, assuming that any data issues can be resolved post hoc. This is a direct contravention of the principles of responsible data management and governance. It ignores the foundational requirement for trustworthy data, which is a cornerstone of regulatory compliance across various sectors. The potential for introducing systemic errors, compromising sensitive information, or generating misleading insights makes this approach professionally negligent and ethically questionable, with a high probability of regulatory noncompliance. Professional reasoning. Professionals should adopt a risk-based, iterative approach to data ingestion. This involves understanding the data's origin, its sensitivity, and the intended use cases. Before implementing any ingestion strategy, a thorough assessment of potential data quality issues and regulatory implications should be conducted. The decision-making process should prioritize data integrity, security, and compliance, integrating these considerations into the technical design from the outset. This proactive stance, often referred to as privacy by design or security by design, is crucial for building trust and ensuring long-term sustainability in a data-driven environment. Regular review and adaptation of ingestion strategies based on evolving business needs and regulatory landscapes are also essential. Question 18. The evaluation methodology shows a financial services firm assessing a new big data analytics platform for enhanced fraud detection. Which of the following approaches best aligns with the regulatory framework and ethical considerations for handling sensitive customer financial data in the United States? Option A. Prioritize a phased implementation, starting with a pilot program on anonymized data, coupled with a comprehensive review of the platform's security, privacy controls, and audit capabilities against GLBA and relevant state data privacy laws, ensuring clear data governance policies and employee training are in place before full deployment. Option B. Implement the platform using existing data handling procedures, without conducting a specific regulatory impact assessment for the new technology, relying on general IT security policies to cover data protection. Option C. Focus exclusively on the platform's predictive accuracy and speed, with minimal emphasis on data anonymization or consent mechanisms, as the primary goal is to reduce financial losses from fraud. Option D. Immediately deploy the big data platform across all customer data to leverage its advanced algorithms for the most comprehensive fraud detection, assuming that the platform's inherent security features are sufficient. The correct answer is A. Prioritize a phased implementation, starting with a pilot program on anonymized data, coupled with a comprehensive review of the platform's security, privacy controls, and audit capabilities against GLBA and relevant state data privacy laws, ensuring clear data governance policies and employee training are in place before full deployment. Explanation. The evaluation methodology shows a scenario where a financial institution is considering the adoption of a new big data analytics platform to enhance its fraud detection capabilities. The challenge lies in balancing the potential benefits of advanced analytics with the stringent regulatory requirements governing data privacy, security, and the ethical use of customer information within the financial services sector. Specifically, the institution must navigate regulations such as the Gramm-Leach-Bliley Act, GLBA, and potentially state-specific data privacy laws, which mandate robust data protection measures and transparency. The professional challenge is to select an approach that not only maximizes the effectiveness of fraud detection, but also ensures full compliance and maintains customer trust. The correct approach represents best professional practice because it prioritizes a comprehensive risk assessment and a phased implementation strategy. This involves thoroughly evaluating the chosen big data platform's security features, data anonymization capabilities, and audit trails against regulatory mandates. It also emphasizes obtaining necessary customer consents and establishing clear data governance policies before full deployment. This methodical, compliance-first approach minimizes the risk of regulatory violations, data breaches, and reputational damage, aligning with the fiduciary duty financial institutions have to protect customer data and adhere to legal frameworks. An incorrect approach that focuses solely on the technical capabilities of the big data platform without adequately addressing regulatory compliance would be professionally unacceptable. This would constitute a failure to uphold legal obligations, potentially leading to significant fines, legal action, and loss of customer confidence. Another incorrect approach, such as implementing the platform without a clear data governance framework or adequate employee training on data handling protocols, would create vulnerabilities for data misuse and breaches, directly contravening the principles of data stewardship and regulatory adherence. These failures stem from a lack of due diligence and a disregard for the legal and ethical responsibilities inherent in handling sensitive financial data. The professional decision-making process for similar situations should involve a multidisciplinary team, including legal, compliance, IT security, and data science experts. This team should conduct a thorough regulatory impact assessment, identify all applicable laws and guidelines, and develop a compliance checklist. The selection and implementation of any new technology, especially in a regulated industry, must be guided by a risk-based approach, prioritizing data protection, privacy, and ethical considerations alongside functional requirements. Continuous monitoring and auditing are also crucial to ensure ongoing compliance and adapt to evolving regulatory landscapes. Question 19. Compliance review shows that a proposed big data architecture for customer behavior prediction relies on processing sensitive personal data. The proposed solution involves aggregating historical transaction data, demographic information, and online activity logs to build predictive models. The architect must ensure this approach aligns with data privacy regulations. Which of the following strategies best addresses the regulatory requirements for processing this sensitive data? Option A. Utilize the existing general consent obtained from customers for improving services as sufficient justification for processing sensitive personal data for advanced predictive modeling without further specific consent. Option B. Implement robust anonymization techniques that render data irreversibly unidentifiable. Conduct a thorough legal review to confirm that existing consent adequately covers the intended predictive modeling, and establish clear data retention policies for the anonymized data. Option C. Proceed with data aggregation and analysis using pseudonymization, assuming that internal use for service improvement negates the need for explicit consent for this specific analytical purpose. Option D. Aggregate and analyze all sensitive personal data directly without any form of de-identification or anonymization, relying on the argument that the data is for internal business intelligence purposes only. The correct answer is B. Implement robust anonymization techniques that render data irreversibly unidentifiable. Conduct a thorough legal review to confirm that existing consent adequately covers the intended predictive modeling, and establish clear data retention policies for the anonymized data. Explanation. Scenario analysis. This scenario presents a professional challenge in balancing the need for advanced analytics with stringent data privacy regulations. The architect must ensure that the proposed big data solution, which leverages sensitive customer information for predictive modeling, adheres strictly to the relevant data protection laws. The complexity arises from the potential for de-identification techniques to be insufficient, leading to re-identification risks, and the need to obtain explicit consent for data processing activities that may not have been originally contemplated. Careful judgment is required to select an approach that maximizes analytical utility while minimizing legal and ethical exposure. Correct approach analysis. The correct approach represents best professional practice because it prioritizes a robust, multi-layered data protection strategy that aligns with the principles of data minimization, purpose limitation, and privacy by design. This involves not only technical de-identification, but also a thorough legal review to ensure compliance with consent requirements and data processing agreements. The emphasis on anonymization techniques that are demonstrably irreversible and the proactive engagement with legal counsel to validate the consent framework are critical for meeting regulatory obligations. This approach demonstrates a commitment to responsible data stewardship and mitigates the risk of significant penalties and reputational damage associated with data privacy breaches. Incorrect approach is analysis. An approach that relies solely on pseudonymization without a comprehensive legal review of consent is professionally unacceptable. Pseudonymization, while a security measure, does not render data anonymous under many data protection frameworks, and re-identification remains a significant risk. If the original purpose of data collection did not include this type of predictive modeling, processing the data without obtaining new explicit consent would violate purpose limitation principles and potentially consent requirements. an approach that proceeds with data aggregation and analysis without any form of de-identification or anonymization, even if intended for internal use, is a direct violation of data privacy regulations. Processing identifiable personal data without a lawful basis, such as explicit consent or legitimate interest, which would need to be carefully assessed and documented, is illegal and unethical. This approach ignores fundamental data protection principles and exposes the organization to severe legal repercussions. An approach that assumes existing general consent for improving services is sufficient for advanced predictive modeling involving sensitive customer data is also professionally flawed. Data protection laws often require specific and informed consent for particular processing activities. Broad, vague consent is unlikely to be considered valid for sophisticated analytical uses that could reveal sensitive insights about individuals. This approach risks misinterpreting the scope of consent and engaging in unauthorized data processing. Professional reasoning. Professionals should adopt a risk-based approach, starting with a thorough understanding of the applicable data protection regulations. This involves identifying the types of data being processed, the intended analytical purposes, and the potential privacy risks. A critical step is to consult with legal and compliance experts to interpret regulatory requirements and assess the validity of existing consent mechanisms. New processing activities are contemplated, especially those involving sensitive data or advanced analytics. A proactive assessment of anonymization or pseudonymization techniques should be conducted, with a focus on achieving a level of data protection that satisfies legal standards. Obtaining explicit, informed consent for any processing that goes beyond the original purpose or scope of collection is paramount. Documenting all decisions, assessments, and legal consultations is essential for demonstrating due diligence and accountability. Question 20. The audit findings indicate that the current big data architecture's ingestion layer is prioritizing raw data throughput above all else, potentially compromising the integrity and compliance of sensitive customer information used in real-time analytics. The architect is tasked with recommending a revised strategy for data ingestion and initial processing, which approach best addresses the audit's concerns while maintaining a balance between performance and governance. Option A. Continue with the current high-throughput ingestion strategy and schedule comprehensive data cleansing and validation processes exclusively in a nightly batch job. Option B. Disable all data validation and enrichment mechanisms at the ingestion layer to maximize data ingestion speed, relying solely on end-user application logic to handle data quality issues. Option C. Implement a multi-stage validation and enrichment process at the ingestion point, utilizing schema validation, anomaly detection, and contextual data lookups to ensure data quality and compliance before it is made available for downstream analytics. Option D. Introduce a lightweight, field presence-only validation check at the ingestion point, deferring all other quality and compliance checks to subsequent, less time-sensitive processing stages. The correct answer is C. Implement a multi-stage validation and enrichment process at the ingestion point, utilizing schema validation, anomaly detection, and contextual data lookups to ensure data quality and compliance before it is made available for downstream analytics. Explanation. Scenario analysis. This scenario presents a professional challenge stemming from the inherent tension between rapid data ingestion for real-time analytics and the imperative for robust data governance and compliance. The audit findings highlight a potential gap where the expediency of data flow might be compromising the integrity and security of sensitive information, particularly in the context of regulated industries. The architect must balance the business need for immediate insights with the legal and ethical obligations to protect data privacy and ensure its accuracy. This requires a nuanced understanding of both technical capabilities and regulatory landscapes. Correct approach analysis. The correct approach involves implementing a multi-layered data validation and enrichment strategy that operates in near real time without significantly impeding the data flow. This aligns with best practices for data architecture in regulated environments. Specifically, it leverages a combination of schema validation, anomaly detection, and contextual enrichment at the ingestion point or very early in the data pipeline. This ensures that data quality issues are identified and addressed promptly, preventing the propagation of erroneous or non-compliant data downstream. Regulatory frameworks, such as those governing financial services or healthcare, e.g., GDPR, CCPA, HIPAA in a U.S. context, or relevant UK financial regulations, mandate data accuracy, integrity, and security. By proactively validating and enriching data, the architect upholds these principles, minimizing the risk of regulatory penalties, reputational damage, and compromised decision-making based on flawed data. This approach demonstrates a commitment to responsible data stewardship. Incorrect approaches analysis. One incorrect approach is to solely rely on batch processing for data validation and cleansing after the data has been stored. This fails to address the immediate risk of using potentially inaccurate or non-compliant data for real-time analytics. Regulatory bodies often require that data used for critical decision-making be accurate and up-to-date. Delaying validation until after ingestion increases the likelihood of regulatory breaches if sensitive data is mishandled or if decisions are made based on incorrect information. Another incorrect approach is to bypass all validation checks for the sake of achieving the lowest possible latency. This directly contravenes data governance principles and regulatory requirements for data integrity and security. It creates a significant risk of introducing malformed, incomplete, or even malicious data into the system, which could lead to incorrect analytics, security vulnerabilities, and non-compliance with data protection laws. A third incorrect approach is to implement a single, overly simplistic validation rule that only checks for the presence of specific fields. While this offers minimal validation, it is insufficient to ensure data quality or compliance with complex regulatory requirements. It fails to detect semantic errors, inconsistencies, or potential privacy violations, leaving the organization exposed to significant risks. Professional reasoning. Professionals in this domain must adopt a risk-based approach to data architecture. This involves understanding the sensitivity of the data, the potential impact of data inaccuracies or breaches, and the specific regulatory obligations applicable to the organization. The decision-making process should prioritize solutions that offer a balance between performance and governance. This includes 1. Identifying critical data elements and their associated regulatory requirements. 2. Evaluating different data processing and validation techniques for their effectiveness, latency, impact, and scalability. 3. Designing a data pipeline that incorporates appropriate validation and enrichment steps at strategic points. 4. Continuously monitoring data quality and compliance metrics. 5. Staying abreast of evolving regulatory landscapes and adapting the architecture accordingly.